Hi folks. At the start of this physics topic we started looking at density. Density of regular shapes, density of irregular shapes, and things like the density of a liquid. Moving on from that just a little bit, we're now going to look at how do substances change as they increase and decrease in temperature. You will have seen something like this at Year 7 or Year 8 in Key Stage 3. And you looked at solids, liquids and gases. These terms for the transitions between solids, liquids and gases are important, so refresh your memory of them, make sure you know which one is which direction they're going in. You melt from a solid to a liquid evaporates into a gas, and a gas can deposit back into a solid going the other way. If you've got a solid that turns straight into a gas, it is doing sublimation, or it is subliming. A gas turning into a liquid is condensing or experiencing condensation, and a liquid turning into a solid is freezing. Again, that should be revision from Key Stage 3. Now we're going to start adding in some more ideas, some more sophisticated understanding of what's going on there. And the first way we're going to do that is the first simulation, which is this one. So if you can get that up on your screen at some point, again, this little button down here enlarges it so you've not got stuff all in the way. The way this works is you've got these two buttons down here which move time forward. Okay, so you don't just press play, you move time forward bit by bit, and as time goes on, this liquid in here is cooled down by this ice bath. If I clear the graph there, every time you press this button, it takes some data from your stop clock here and the thermometer. So if we took one at time 0, it starts off at 20 degrees at time 0. You don't need to do every 10 seconds, every minute is fine. If I take all these data points first, then we can have a look at what is happening, because it's difficult to see everything that's happening at once, but if you go back and forth a few times you can start to put it together. If you look at the pattern that's forming on that graph, you should see that the temperature dropped initially when we put it into the ice bath. Then something a little bit strange happened. The temperature stopped falling. It just kind of leveled out there for some reason, and then the temperature started falling again. If we rewind back to the beginning, and this time watch this simulation, so rather than looking at the stop clock or the temperature going down or looking at the graph, watch this here. So a few seconds in, a couple of minutes in, we just see the gauge on the thermometer going down. So it's cooling down slowly, 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 and then it stops falling. Now, if we look at the liquid itself, you see that while the temperature has stopped falling, something else is happening to the liquid. Okay. The liquid is changing colour. It's a little bit of a funny part of the simulation, but it is freezing. It is turning from a liquid into a solid, and during that period, during that time period, the temperature is not changing. Once it has fully turned into a solid, once it's fully frozen, turned into ice, the temperature starts falling again. Okay. This is because, and you should remember this from Key Stage 3, solids have got bonds in between the particles. Liquids don't have as strong a bond. They're able to swap bonds from one particle to the next, having these weak forces holding them together. Solids have got much stronger forces, much more rigid bonds. They are bound to the particles that are above them and below them and to the sides of them. Okay, they can't change their bonds with things that are nearby. Liquids can. When those stronger bonds form, a little bit of energy is released. So while our liquid is freezing, turning from a liquid into a solid, a little bit of energy is being released into the liquid. Not enough to heat it up, but enough to stop the temperature falling anymore. Once all those bonds are formed, that's all the energy released from those bonds forming, the temperature starts falling again. You can think of it a little bit like the liquid can only do one thing at a time. It can either decrease its temperature or it can change state. There are different liquids where you've got mixtures of things where you will see it changing state and changing temperature at the same time. But for the time being, if you've got a pure substance, it can either change temperature or change state. And these flat sections on these kind of graphs are changes of state. These steep sections, or the curved sections, are changes in temperature. So that was just a little one showing a liquid turning into a solid. If you look at the second simulation, this one, I'd like to spend quite a long time on this one, having a look, having a read, having a think about what's going on, because it's also got some description here. So I'm not going to spend too long talking about it, because you can just read through it, but I'll just point out a few things to help you get the most out of the simulation. So we start off with a solid. In solids, the particles are vibrating, they've got energy, they vibrate back and forth, they don't go very far, and they don't change their orientation, so they don't change position compared to each other. They're not swapping places, they're just jiggling in place. We can start to give this solid, this could be something like a block of ice, we could start to give it energy. We could start to heat it up. At first, those particles are just going to start vibrating more. It's not going to start to melt. If we go from a block of ice at minus 20 degrees to a block of ice at minus 10 degrees, that's not melted, but it has got more energy, so those particles will vibrate more. If we keep giving it more and more energy, what I said about those bonds starting to break, so all these particles, they're now able to change position a little bit more. So if we go back again, in this particular one, so when you click on 3, this little animation works across here. Remember I said that the flat sections are changes in state. So we're going from a solid at the start to a liquid. So as we break those bonds, that requires energy. It requires energy to break a bond. So at the start, every time we add a little bit more energy, the temperature goes up. We start off with it cold down here, we add a bit of energy, temperature goes up, add a bit of energy, temperature goes up, add a bit of energy, temperature goes up, until it gets to this point here. Then the energy stops being used to raise the temperature, the energy is used to break these particles' bonds. That's why it goes from being a rigidly bonded structure like a solid to a lightly bonded structure like a liquid. So these particles, they're still sharing small bonds, small forces with each other, because they're not flying off and becoming a gas yet, but the bonds are not nearly as strong as when it was a solid. Increase the temperature some more. So again, we're adding some energy in, heating it up, the temperature's increasing. All it's doing is vibrating faster. Those particles are moving around more. If we keep doing that, eventually we're going to add enough energy that the liquid bonds between those particles can break as well. So we end up getting evaporation and it becomes a gas. And again, just like when we went from a solid to a liquid, this transition here, the temperature stayed the same. When we go from a liquid up to a gas up here, this change across here, the temperature stays the same. Okay?